Hello everyone, I'm Jevika Kancharla and I'll be explaining you guys the solving of second question in homework 6 of the course Probability in Stochastic Processes. Before we go into the solution, let's have a look at the question. It is given that the probability density function of x, y is equal to b if x square plus y square is less than or equal to 1. Otherwise, the value will be equal to 0. Now we're supposed to find three parts here. So in the first part, we have to find b so that the above defined function is a valid joint probability density function. Now let's have a look at the solution. It is given that f of x, y is equal to b if x square plus y square is less than or equal to 1. The value will be equal to 0 otherwise. Now we're supposed to find b, that is from integral minus infinity to infinity f of xy into dx dy is equal to 1. Now we know that the value ranges from x square plus y square is equal to 1. Therefore, this will be the line of x square plus y square equal to 1. That is, the radius of this circle is equal to 1. Now the area of this square is equal of this circle will be pi r square, and we know that the radius is 1. Therefore, it is pi into 1 square. And the circumference of this circle will be equal to b into pi. Therefore, the value of b is equal to 1 by pi. In the second part, we are supposed to find expected value of x, expected value of capital X given y, expected value of x given y, expected value of y, expected value of x, y given x, expected value of y given x, and expected value of x comma y. Now let's look at that. E of x is equal to integral over f of x into f of xy dx dy. Now we know that f of x comma y is equal to b. Therefore, b is 1 by pi. So 1 by pi into x into dx dy. Now, the limits for dx will be from minus into 1 minus x square root 1 minus x square dx into dy. Now, since this is an odd function, the value of e of x will be equal to 0, which implies that e of x given y and e of x given y will also be equal to 0. Now let's calculate probability expected value of y, which is equal to integral minus infinity to infinity y into f of x dx dy. Now once again, since we know that f of x comma y is equal to 1 by is equal to b, which is equal to 1 by pi. Now if you solve this function, you will be getting this value, which is an odd function. Therefore, e of y is equal to 0, which implies e of y by x is equal to 0, and also e of y by x is also equal to 0. We are also asked to calculate the expected value of x comma y, which is equal to 1 by pi integral from minus 1 to 1 and integral minus 1 minus x square into root 1 minus x square x y into dx dy. Now this will be can be rewritten as integral from minus 1 to 1 x into integral 1 minus root 1 minus x square into root 1 minus x square y into dy dx. Now, since in this, while solving e of y, we have taken that to be an odd function, therefore this will be an odd function, therefore the expected value of e of x comma y is equal to 0. Therefore, all the values that are asked here will be equal to 0. Proof, in the third part, we are supposed to prove or disprove that x and y are uncorrelated. Since here, while solving, we calculated the expected value of x and expected value of y, where both of them are equal to 0, and the expected value of x comma y is equal to 0. Therefore, e of x comma y is equal to e of x into e of y. Therefore, both x comma y are uncorrelated. Therefore, this is the solving of second question of homework 6.